Hello and welcome to another CS Tutor Center video. Today we're going to talk about the Leetcode problem, minimum size subarray sum. So let's get started. First what we'll do is we're going to read this description and we're going to look for keywords that tip us off as to what coding pattern we can use. And then when we have that tip, then we're going to look at the constraints and see if there's anything in there that would tell us, no, don't use this pattern. We're also going to think about the big O. When we read this problem, we're going to think about, is there a, is there a big O that's not possible for me to go faster than? Okay, and all these things will help us be able to figure out how to get started on this. So let's read this. It says, given an array of positive integers nums and a positive integer target, return the minimal length of a subarray whose sum is greater than or equal to target. If there is no such subarray, return 0 instead. Okay, so the keywords that jump out to me is this right here. Minimal length of a subarray. Okay? That's those keywords are what show up for solving sliding window problems. Because with a sliding window, you are looking for, one of them can be the minimal length of a subarray. Here, let me show this list here. Here's a list I produced of some keywords to look for in a problem that will tip you off to using the sliding window pattern. Okay, so if these are the types of problems that a sliding window can solve. So here we are, we're at the shortest sequence, right? So basically I put a sub bullet under that to say that one such source sequence that they could be asking for is the minimum subarray, right? And that's what they're asking, the minimum length subarray. And in here I say in the exact sequence as the original, right? So what that means is, when we make a subarray like this, here's our blue highlighted subarray, we're in the same sequence as the original. The 2 is there, then the 3, then the 1. We're not finding one where these numbers are flipped around. Okay. Next, I want to think about the big O real quick, because I know if I'm doing a sliding window, then I'm going to be having a linear. In this particular sliding window problem where I'm just getting a subarray, from experience, I know I can do that in linear time. And you build that up as you solve more sliding windows problems. So linear, right? Linear for the sliding window problem. Let's take a look at if it's even possible to solve this problem faster than linear. And the answer is no. Let me explain why. Look at this array they give us, right? In this array, we need to find a minimum subarray. So if you didn't know, when we start out, we don't know what's in this array. So I'm just going to put question marks to signify that. So we don't know what's in this array. In order to know the minimum, length subarray, we have to at least look at each one of these. We have to reveal at least each one of these. And that means that the best we can do is linear, because we have to look at least each one of these. Okay. And that's because, big O of n, at the minimum, we're going to have to look at all n. at least once. So we know we can't do any faster than linear, so good. We're still good with a sliding window problem. Perfect. Let's go down here, the constraints. Oh, I like this. I like to see that the length of the array isn't ginormous. Because if this was like something like 10 to the 9, you know, if this was like a massive length array, then I wouldn't be trying to do a linear problem because it would just take way too long. Okay, good. So we're doing sliding window. We already know it has to be linear anyway. We know it that checks out with our sanity check on the length of the array. Okay, let's look at some other things with constraints. Like we know they passed in a target that's an integer, and we know that the value of target can fit in an integer. We know that the values of the numbers inside of the nums array can fit in integers. So, quick question. If I'm summing these, like let's say I highlight this. Let's say I highlight this. We know that's the answer, right? Because it says it right here. But we also know it's the answer because 4 plus 3 equals 7, and 7 is the target. And a length of 2 items is the smallest we can do to make up 7 or greater. So when I added that in my head, you know, I added 4 and I added 3. When we go to write code, we're going to need to store that addition somewhere. And here's a question. Can we use an integer to store the sum of these numbers? Let's go look at the constraints and find out. So the target is 10 to the 9. Okay. That can fit it in an integer. When we're doing our summing, we're going to loop over the nums. And each num can be 10 to the 4. So let's look at the extremes. If I sum 10 to the 4, let's assume this whole thing, each item inside of this array is 10 to the 4, and there's 10 to the 5 of them. So if I sum all that up, is that going to fit in an integer? Yes, it is. So we can use a integer to store our sum. Okay, now let's get down to thinking about this problem. Okay, so sliding window problem. When we're sliding, basically it's as it sounds, as you have some window and it slides from left to right, and this window can grow and it can shrink. Now, whenever you do a sliding window problem, you want to think to yourself, do I need to shrink this window? Because that's not all, you know, that's not always the case. Some of the sliding window problems, they grow and they slide, but they don't shrink. So you want to think, do I need to shrink it? Well, in our case, we want to find the minimum. We want to find the minimum subarray. So in your notes, to tip you off as to if you want to shrink, if the window is going to need to shrink or not, know that in a problem where you need to find the minimum subarray, that's a scenario where you're going to want the window to be shrinking. Okay, let's see why. All right, so we're going to start out here. First loop, we have 2. So we have a sum of 2. That is not greater than or equal to 7, so our target is 7. So we're going to grow this. So 2 plus 3, which is 5, so that's still not 7, so we grow this. We're going to add 1 here, so that's 6. Still not 7, so we grow this. Plus 2, so now we're at 8. So now 8 is greater than, or equal to 7. So we're going to capture our minimum length. So our minimum length, when we write the code, we're going to do the index 3, which is the end of our window, minus the start of our window, which is 0, plus 1. We just add 1 because you get the difference between the start and the end, and then plus 1 to account for the length of it. So that's 4 total. Okay, so now we have a potential minimum length solution here. It is greater than the target, so we're going to shrink the window. Notice that the 2 just left the window. So what we're going to do here is when we work on our sum, when we work on our sum, we're going to subtract that 2 from it out of the window, right? So sorry, we had it like this. So we subtracted the 2 out of the window, and so that goes away, and now we just have 2 plus 3 plus 1, which is 6, which is not greater than or equal to 7. So we're not going to update the minimum length. Okay, growing the window, so we grow it, plus 4, so now we have 10. Okay, and this length is not smaller than the our current minimum, so we don't need to update the minimum. It's already 4. 10 is greater than or equal to 7, so we're going to remove. We're going to shrink the window, remove the 3 from it. So remove the 3 from this window. So now we got 1 plus 2 plus 4. So this is 7. And this is this is 3, right? So that's less. So we're going to update this. So there's our minimum length of 3. And then we're going to increase the window. So now we have a plus 3, which is 10. That's greater than or equal to 7, so we shrink. So take the 1 out. So that's 9. Okay. And then we shrink again. Take the 2 out. And now that's 7. Great. It's greater than or equal to 7. It's also less length than the current minimum length. So we're going to update this. And then that's our solution. 2 is our solution. Okay, so now we got to write code for this. So let's dive into that. Remember, we started here. So let's go write code starting there. So we had the sum, right? I'm just going to call that current sum. And then we had the minimum length. I'll call that min length. And then we can do this, integer dot max value, right? To start it out like that. And then when we find one that is smaller than this maximum value, we can update it. Or, when we look at these constraints here, we see that our nums.length, or not the constraints, sorry. When we just think about the problem, let's just think about the problem for a second. So we need to find a minimum length subarray. Okay, so let's look at this subarray here. There's 1, 2, 3, 4, 5, 6, right? That is the smallest subarray, or that's the largest subarray we can have, is 6. So if we just started with a 7, nums.length plus 1, that's like an impossible state. And the reason why we would initialize this with an impossible state is so that, you know, when we do find a solution, then when we check to see if that solution is greater than, or sorry, that solution is less than this minimum length, that we update it on the first go around. And we can do that by just setting minimum length to be a length that is greater than any possible minimum length this solution can provide. So let's start with window end being 0, window start being 0, and then there we go. And window end being less than nums.length, and then window end plus plus. Okay, that's because we're starting with window end here. So we got window end. So window end's going to want to start right out at 0 here. And same with the window start is going to want to start out at 0 as well. And what we're going to do, let me create another text for this. The start is going to represent the beginning of the window, and the end is going to represent the end of the window. So the beginning, the start, and the end are at 0, which forms this window here. Okay, so we will say current sum plus equals nums of window end. So window end is at 0. So we add what's at 0 to our current sum. So that's 2. And then you can see each loop, you know, next this will get bigger, right? Because we're going to increase that window by 1. And we would add where the we would add that new number that entered the window. And it would just continue to do that. So remember, we had that logic that like once we found a solution, we updated the length, and then we reduced the window to see if we can find a better solution. So let's add that in there. So first, let me get up to a point where we have that scenario. So in this scenario, we have 2 plus 3 plus 1 plus 2, which equals 5, 6, 7, 8. So 8. So we would update this minimum length. And then we want to find a better solution now. So we would shrink as long as, we're going to shrink as long as the sum is greater than or equal to 8. Okay, so let's update to have that. So as long as the sum is greater than or equal to target. I said 8, sorry, I meant 7 in that, in our, the target is 7 in our scenario here. So as long as the sum is greater than or equal to target, we will shrink the window. Okay, so here's the part where we shrink the window. So let's look at this. We say this adds. So here we go. So this adds, and currently it's 2, so it's not greater than or equal to target. So it doesn't come inside of this while loop. And then it's going to loop up and increase the window end. So window end moves up here. So that adds what entered the window. Now we got 5, not greater than or equal to the target. Then we increase here. Let me just put what the let me have a note here for us that the target is 7. Okay, so still not greater than or equal to the target. Goes back up here, increases the window size, adds 2 in it. Is greater than or equal to target. Updates minimum length. So minimum length, remember we set minimum length to be 7. And we did that because there's 6 items in here. So the smallest we could have is 6. So if we found that, then we would want to update that. So when we start out the minimum length, we have to set it equal to something, and we'll just set it to be a number bigger than what we can possibly have, so that when we do this math.min, the one that we did find will overwrite it. Okay, so in this case we have 3 minus 0 plus 1, which is 4. And then we're going to shrink the window. So we shrink this window. So we subtract 2 out of this because that just left the window. So now that's 6. That breaks the while loop because it's not greater than or equal to the target. Go back up here and increase the window size. So that adds 4 to this, which makes that 10. And that is greater than or equal to the target, comes in here at size 4 already, reduces the window size. So we just removed 3 from that window. So now we have 4, 5, 6, 7. And the window size here is 3, so that's smaller, so we update that. And then we shrink the window again because the sum is greater than or equal to the target. So the sum is currently 2. The 1 left the window. So the sum is 2, which is no longer greater than or equal to the target. So we the while loop breaks and we come over and increase the window size. What comes into the window now is 3, so we add 3. So this is 7, 8, 9. And then it's greater than or equal to target. And so we shrink the window size here. So 2 left the window. So now we have a 7. We update the length to 2. And then we try to shrink it again, which is not equal to the target. So that breaks. And then that increases, and that window end is now no longer less than the length. So here, the minimum length is 2 now. So we can't just return minimum length, because remember, if we didn't find a solution, it wants us to, if we don't find a solution, it wants us to return 0. So we need to check to see if it's equal to this, which means no solution. So if minimum length equals that, then return 0, otherwise return minimum length. Okay, so maybe we would accidentally say 2 or something like that. So instead of that, what we can do is just say like final int like no result equals this. This signifies no result. Okay. And then we'll run it. I'll run it here. And it passed the test cases, and then I'll submit it. And then it passed the it accepted it, right? Okay, so let me show the other way real quick. So a lot of times you could just if you're in Java, I mean, you could just do this. It'll be faster. And integer dot max value. That's kind of standard here. That's gonna also be acceptable. Okay, let's look at what it looks like in Python. So in Python, I wrote it over here already for us. So you can take a look at that. That's what it looks like in Python. All right, well, thanks everybody. Go ahead and like and subscribe. Let me know what you think in the comments. I'm going to produce more of these, and I'll talk to you later.